you guys. I hope everyone's had a great week so far as we've adjusted to distance learning. I know that you've probably been on information overload right now with all of your teachers posting their directions and their expectations, and on top of that, assigning you work to work on. My best advice to you is just to take a deep breath, make a list of all the stuff you have to do, keep an agenda, and just try your best to stay on top of everything. So with that being said, we're going to go ahead and jump into our next lesson, which is in Unit H, Lesson 2. We're going to continue talking about sequences and series. Today's topic is actually something different. It's series, not a sequence, and I'll explain what the difference is. We're also going to talk about what the definition of a partial sum is, and what sigma notation or summation notation looks like, and how to interpret that and use it to solve problems. So let's go ahead and just get started. As always, it's super important right now with this, submitting your notes online, that you need to make sure that you put your name. So I'm going to put my name on top of my notes. And it is Friday, and I don't even know what day it is, the 3rd, right? I think it's April 3rd, 20. And our topic today is going to be Unit H, and this is Lesson 2. And then you're going to put your period number here. Okay. All right. So the first thing is we're starting to talk about series, and this is a little different from what a sequence is. It's in the same ballpark. It looks like a sequence, and so what you're actually doing though is, instead of trying to figure out what's the pattern that you're going to use to predict what the terms are in the sequence, a series is actually just a sum of the sequence. So let's go ahead and just jot that down in our first blank here. It is the sum of the terms in a sequence. Okay, so let's look at some examples. So we know, looking at this first one right here, this is a set. There's 4 terms in this sequence, and I know that there is only 4, and it doesn't continue because there is not an ellipsis here at the end. There's nothing signifying that there's more terms after the number 4, okay? So this is the sequence, and then the series would be the sum of the terms that are inside the sequence. So I would literally just add 1 plus 2 plus 3 plus 4, and I would have the series, well, the summation. So let's go ahead and add that up, and what we end up with is 10. And then if we look at our second example, we have a sequence here that has an ellipsis at the end, which signifies to us, that we learned in section 1, that this sequence is going to continue on infinitely. There's an infinite number of terms. So my only question that I'm going to ask myself here is basically, is this sequence a pattern where the numbers are getting larger, like each term is a larger number than the one before it, or not? So in this case, it looks like it is, because 6 is larger than 3, and 9 is larger than 6, and 12 is larger than 9, and so on and so on. So if you continued adding the terms in this sequence forever and ever and ever, because that's what this ... implies, is that it goes on forever and ever and ever, you're going to end up with infinity as an answer for your series, because there's not a way to quantify what the sum would be if you continued adding everything together. So we're going to go ahead and put an infinity symbol here, and that would be the answer for this one. The last example they gave us here is another sequence that goes on forever. There is a ... ellipsis here at the end, signifying that the sequence continues. So you don't know what term comes after 1 over 16, though you could probably guess at this point what the pattern is. I do have fractions being added together, and so I want you to take a moment to just think about what happens when you add the 4 terms that you do have inside of the sequence. What happens when you add up those fractions? Each term is getting progressively smaller than the one before it, okay? So what is this going to add up to? You might be thinking something like infinity again, but that would not be accurate, so think about it, and I'm going to pause the video for a moment so you can think. Okay, so it's times like these where it might be easier for you to try and visualize this if you pull up a calculator. So I'm going to go ahead and put mine on, and I'm going to just start adding the terms together. So here's 1/2 and 1/4 and 1/8, which is the next term, and then the one right after that is 1/16. So right there, that number of those first four terms, that sum of the first four terms is 0.9375. So it's kind of getting close to a whole number. It's kind of getting close to 1. And how can I prove that it's going to get closer and closer to 1? Well, what would be the next term in this sequence? It looks like all the denominators are just a double of the previous denominator. So the next term in this sequence would be 1/16 times 2, which is 32. So let's go ahead and add 1/32 to our result here. So is that new result closer to 1 than the one before it? And the answer is yes. It's getting closer and closer to 1. 0.96 is closer to 1 than 0.93 is. And then let's go ahead and add the next term, which is going to be 1/64. And that's even closer to the whole number 1. Keep going. The next one would be 128. Okay, 0.99, that's pretty friggin' close to 1. Okay, and then let's just do it one more time. So the next term would be 1/256. So it's still 0.99, so you've got to kind of look at more decimal places, and you can see that it's even closer to 1. Since this series continues forever and ever and ever, if I continued this pattern in my calculator for 10 or 15 or 20 more terms, I would be so close to 1 that I could taste it. Okay, so I'm literally just going to put 1 here as my answer. That's the answer for this series. All right. Okay, so let's move on to the next section on the notes, which is about partial sums. So what is being asked of you in a partial sum is to find what the sum of some of the terms are. Haha, that was funny. Sum of some of the terms. You're looking for the sum of some of the terms, and the problem is going to tell you how many terms that they want you to add together to find that sum. It's a partial sum, not a complete sum, because if you take a look at all 4 of the problems they gave you, these sequences, they're all infinite, right? They continue forever. So there's really not an easy way for you to quantify what the series or the summation of that series would be. So instead, we're going to ask you, what is the sum of some of the terms that are inside of that sequence? So let's go ahead and show you how that works. Let's define what a partial sum is first. The first thing you need to know is that a partial sum is going to be denoted by a large S with a subscript of n, and n is going to tell you how many terms they want you to add together. So a partial sum is the sum of a specified number of terms. So let's look at number 1. We've got 1, 2, 3, 4, 5 is in our sequence, and they want us to find the summation or the partial sum of the first 9 terms of the sequence. So how many terms were we given here? 1, 2, 3, 4, and 5. That's not 9 terms. So I need to figure out what the rest of the terms are to get me to the 9th term. And I think you can tell pretty easily what the pattern is here. It's just adding 1 every time. So the next term would be 6, and then 7, and then 8, and then 9. But that's not all they want you to do. They also want you to find the sum of the first 9 terms at this point. So what is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9? Okay, so that's what they're trying to have us figure out. And when you add that together, you get 45 as an answer. So that's the result for this one. That's all there is to it. They're going to give you the sequence, and they're going to tell you how many terms they want you to add together. Okay. Let's take a look at number 2. We have a sequence which is 4, 7, 13, 25, 49. Before you even try to start figuring out what's happening in terms of like the pattern that's going on in the sequence, look at the problem, because they want us to just find the sum of the first four terms, and the first four terms were already given to us right here. So it's done already. Basically, we don't have to figure out any more terms. We just need to add them together. So we're basically going to add 4 and 7 and 13 and 25 plus, plus, plus. And then what is the result of that going to be? Well, if you add that together, you get 49. So there you go. So I'm going to go ahead and do 3 and 4, but something that I want you to do right now while you're taking your notes is I want you to click pause on this YouTube video. I want you to click pause, and I want you to attempt 3, and I want you to attempt 4, and then I'm gonna go ahead and do them so you can unpause the video and see if you got the answers correct, okay? So go ahead and do that. And then, so when you come back, I will be explaining the next two problems. So on number 3, they want me to find what is the partial sum up to the 6th term. So I was given 5 of them, and I only need to find out what the next one is. So let's try and figure out what the pattern is that's happening here. So it looks like the first term is 1, second term is 4. So if I'm going to look at it like addition, I'm adding 3, but then from 4 to 9, I'm adding 5, and then from 9 to 16, I'm adding 7. That's not really like a pattern I can follow. But something else I notice about these numbers in the sequence is that they're all perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the next term would be 6 squared, which is 36. Okay. Now I have 6 terms, and I can go ahead and add them together. And when I do add them together, I end up with an answer of 91. And number 4 is another partial sum. They want us to find the sum of the first 3 terms. I'm telling that because in the subscript, in my notation here, it's telling me to do the third up to the 3rd term. So that's going to be this one and this one and this one added together. So just add them together, and you will find an answer of 11 over 6. Okay, circle my answer. All right. If anything in the notes have confused you so far, I want you to make an asterisk next to it, or highlight it, or somehow otherwise notate it so that you know that that's something that you're going to need to come and ask me about the next time that we have a Google Meet, okay? I'm going to go ahead and move forward in the notes. The next thing that's on the list here in our notes is summation notation. So I'm not sure if you've heard this terminology before. I think it is something that's covered in Algebra 2, but it is sometimes is not done till like close to the end of the year, and then if you know, you might not have gotten time to get to it. So this might be new for you, it might not be, who knows, but we're going to dive right in and do it. So let me just get a sip of my coffee here. Hold on. Okay, so summation notation is a way to represent a series using the Greek letter sigma. That's what this little E shape is. It's called sigma in Greek notation. Okay, this is a capital sigma. Okay, so you might hear me interchange the words where I say like sigma or summation or something, and then you just need to know those things are related. All right, so let's kind of break down what a problem is going to look like when it's in sigma notation or summation notation. So at the very bottom of the sigma character, what they're telling us is what is the first term number that they want us to do inside of the sequence to add together. So we're going to put first term number. Please notice, please take note. This is not telling you what the value is of the first term. It's not telling you that at all. It does not tell you the value of the first term. This is just simply saying start at the first term in the sequence, okay? And then also at the top of the sigma, it'll tell you where to stop, okay? So this is going to be the last term number. Once again, this is not the value of the 5th term or the last term. This is just telling you start at 1 and go to 5 and stop there, okay? And then finally, what is next to the sigma notation is going to be what the formula is for the sequence. Okay, so we're going to put sequence rule or formula. Okay, whatever one you're more comfortable writing, go for it. Okay, so what we can do is we can actually, this is a complete problem, so we can actually find what the sum is of this series. Okay, what's the summation here for this one? Okay, and what we're going to do is for the first term when n is 1, we're going to calculate what is 2 times n. Well, if n is 1, then 2 times 1 is going to give me 2. So the first term is 2. Let's find the second term. So when n is 2, what is 2 times n? Well, if n is 2, 2 times 2 is going to give me 4. So this is going to be plus 4. Let's find the next term. The next term will be the third term. So 2 times 3 is going to give me 6. The next term is the fourth term. The fourth term is 2 times 4, which is going to give me 8. And then my final term is going to be the fifth term because it's telling me to stop at the fifth term. So 5 times 2 is 10, okay? These are the terms that are in this sequence represented by this rule, and this summation is telling me to add the first 5 terms that are in that sequence, okay? So when you add them together, you're gonna go ahead and you're gonna get 30 as an answer, and that is the answer to this problem. So the answer should be a number, all right? I'm going to go ahead and do number 5, and then I want you to do like what we did before, and I want you to pause the video and attempt to do number 6 on your own, and then I'm going to go ahead and do number 6 so you can confirm if you got it right or not, okay? So let's look at number 5. I'm going to zoom just a tiny bit because I'm not sure if that's really legible or not, but it's basically telling me to find the summation, start at the first term and end at the 12th term, and here is the formula for the sequence. It's n minus 1. Okay, so what we can do, another way that we can do this is instead of computing what this comes out to for each term in our head, we can write the problem out using this formula. Okay, so let's make a table, and let's say that those are our values for n. Okay, and we're going to have 1, 2, 3, 4. I didn't make enough space in my table. That's okay. We can expand it. 7, 8, 9, 10, 11, 12. Okay, let's continue with this here. Make the table a little larger. All right, let's split all these up. Okay, so in the bottom of the table, we're just going to use we're using this table so we can keep better track of what each term comes out to be. Okay, so when n is 1, let's plug that into our formula, and let's put 1 minus 1. So what do we get? We get 0. Okay, and then 2 minus 1, 1. 3 minus 1, 2. 4 minus 1, 3. Do I need to? So stop what you're doing. Okay, put your pencil down and evaluate here. Do I need to keep taking n, plugging it into my formula, and finding out what the result is? Or have I figured out what the pattern is that I'm doing every time and I can just finish the table? At this point, you should be able to figure out what the pattern is, which is that you're adding 1 to the result every time. So 4, 5, 6, 7, 8, 9, 10, 11. Another thing to look at is that whatever the term number is, you subtract 1, and that's the result for that term number. Okay. All right. So the question said to find what the summation is of this series from the first term up to the 12th term. So you're going to go ahead and add all of these answers that you got in the bottom here, and that's going to give you your result. And the answer that we find here is 66. Okay. I'm going to go ahead and continue to do number 6. What I want you to do now is I want you to pause this video and work number 6 out, and then unpause the video and watch me do it and see if you got the same answer. Okay? So go ahead and pause now, and I'm going to go ahead and continue. So if I'm looking at this question, it's telling me to find the sum of the series from the first term up to the 7th term. So I can use what I did before and make another table. So let's make a little table with our n's here and what our term values are. So when n is 1, 2, 3, 4, 5, 6, and 7, because they only want me to go to the 7th term, okay? Let's make this table with some lines. Okay, if I plug in 1 for n, the first term is going to be -3 times 1, which is -3. And then the next term is going to be -3 times 2, which is -6. The next term is -3 times n, which is 3. So -3 times 3 is -9. Okay, I'm going to keep going here with this pattern. The next thing is going to be -12, then -15, and then -18, and then -21. Okay, so when I add all of these terms together, let's circle this up. That's the summation. We need to add those together. We're going to get a value of -84. Okay, so that's basically all there is to it. Let me just flip real quick to my next page and look and see what other types of problems we have. Yeah, they're all plugins basically. So some of them look like they might be slightly more complicated than others. So, but really, the new information that you just got about how to understand what a series is in Sigma notation and how to do one of those problems, that is the new information. The rest of it is just plugging in. And at that point, it's basic algebra. And so that's not new information. So it might, if you're doing these, you're not getting the right answer. It could just be, you know, like a calculation problem or an algebra error. It's not that you don't understand what a series is, because I think you pretty much can get it, okay? I'm going to skip 7 and 8 because those are just like the ones we just did. I am going to go ahead and I'm going to go to let's tackle number 10 because 10 looks like it might be slightly difficult. So let's interpret what this is saying. Our rule for our sequence is that we take whatever the term is, the term number, and we cube it, and then we divide that result by 2. So that's all new, okay? Another thing that looks new here is that instead of it calling the term number n, they're calling it c. Okay, so don't let that trick you. Okay, it's meant to trick you, but don't let it trick you because C and N are just interchangeable. The term number is 2 that you start with. The term number you end with is 8. It's just like if this was N. Okay, that's all this is. So let's go ahead and do this. I also want you to take notice that we're not starting at the first term here. We're starting at the second term. So we're going from the second term up to the 8th term. Be careful with that because if you always by default start at the first term and they only wanted you to find something later like the 2nd through the 3rd or the 5th through the 10th term or something like that, your answer is not going to be correct, okay? So let's go ahead and look at this. Let's make a table. So instead of N, I'm going to put C. And C starts at 2. 4, 5, 6, 7, 8. Those are all of my term numbers. Now I need to calculate what the values are of those terms. So when C is 2, we're going to plug that in. 2 gets cubed, and then you divide it by 2. Okay, so 2 cubed gives us 8. Okay, so that's 8 divided by 2, which is 4. The value for the second term is going to give us a 4. Okay, let's go ahead and plug in 3. 3 cubed is 27. 3 times 3 is 9, and then times 3 again is 27. So 27 over 2. Ouch, that's not a nice clean number to look at. I'm going to go ahead and tell you that you can use decimals, okay? So half of 27 is 13.5. I'm doing that because as you go through this, you might figure out that like 2 of them have a 0.5 and therefore they make a whole number. Does that make sense? So your answer might end up being something that doesn't have a decimal attached to it, okay? Okay, so 4 cubed gives us 64, and then we're going to take 64 and divide that by 2, which is 32. Okay, so we're just plugging in the whole time. 5 cubed is 125, and then you divide that by 2, and you get 62.5. Okay, so note to self, I could have made these slightly larger, knowing that there was going to be decimals in them. Oops, sorry. 6 cubed gives us 216, and we're dividing that by 2, which is going to give us 108, which I'm writing down here. And then 7 cubed gives us 343 divided by 2, which is going to give us a 171.5. And then finally we get to the 8th term, and the 8th term is going to be 8 cubed, which is 512 divided by 2, and that gives us a 256. So I'm going to go through now, and I'm going to add 4, 13.5, 32, 62.5, 108, 171.5, and 256. Okay. When you add all these together, you get 647.5. Okay, that is the result for this question. It's basically the same process every time. Figure out what is the range that you're looking at. So this one's from 2 to 8. And then break it down and do each term individually, and then add all the terms together. And that's basically all there is to it. Okay. Now, you might be thrown for a loop on a question like number 12, because what you have here is you have a 3 that is being multiplied by all of this. Okay, so think about this, you guys. If you go back to one of our past problems, like number 10, okay, all of this right here, this sigma notation, is a number. Once you do all the work, you get a number as a result. So if you look at number 12, it's going to be all of this work that gives you a number that you must multiply by 3 at the end. Does that make sense? So it's going to be 3 times, and then I'm going to make a big bracket here because I want to keep all the work for the summation in one place so I can calculate it. Okay, and then I want to multiply whatever all that comes out to by 3. Okay. I don't think I'm going to need to make a table this time, but just take note, please, that you're starting at term 4 and going to term 8. So 4, 5, 6, 7, 8 is going to be 5 things that you're going to be adding together here. Okay. So if the first value of P or N or C or whatever letter they want to use, if the first value of P is 4, that's going to be 4 minus 4, and you square it. So 4 minus 4 is 0, and 0 squared is 0. So the first term is 0. Second term is 5. So 4 minus 5 is negative 1, and negative 1 squared is a positive 1, so plus 1. Next term is 6. 4 minus 6 is negative 2. Negative 2 squared is positive 4. Next thing is going to be, let's see, 4, 5, 6. So the 7th term, so 4 minus 7 is negative 3. Negative 3 squared is positive 9. And then the last term is going to be term 8. 4 minus 8 is negative 4. Negative 4 squared is positive 16. Okay, so what does all of this add up to on the inside here? It adds up to 30. So this is going to be 3 times the value 30. And so the answer here would be 90. Okay. Okay, so here's what I want you guys to do. So if we flip to the first page, it looks like we did all of the problems. So on the second page here, your classwork assignment that goes with this video is going to be 7, 8, 9, 11, and 13. So you have 5 problems to go with this. I'm going to zoom out so you can see all that. Okay, so, oh, it doesn't go out any further. Whoops. Oh no, my camera crashed. Okay, hold on one second. Let's just reopen that sucker. Okay. So that was not cool. I think maybe I tried to zoom out too much and the camera like freaked out and couldn't do it, so whatever. So this, I'm gonna put a CW next to this. That's 7, 8, and 9. That's classwork. I want you to complete that. And also 11 is classwork and 13 is classwork, okay? So we're going to do similar to what we did last time on Wednesday. I'm going to give you 2 grades for this lesson. The first grade is going to be for completing the notes, which will be all the information that I went over with you in this video. And then the second grade is going to be like your classwork, homework, whatever you want to call it. And that's going to be completing these 5 problems on the second page, which is 7, 8, 9, 11, and 13. I'm just going to have you upload one thing to Google Classroom. It's going to be these 2 pages. And if it's completely 100% filled out and it's good to go, that's going to be a full grade. And then we can ratchet it down from there, depending on how much you've actually done, okay? So I hope that was a helpful lesson for you guys today on series, partial sums, and sigma notation or summation notation. Give these problems a shot, and then if you get stuck on anything, you have some options. One, you can contact me. I can try and help you out as best I can in the moment. I can send you some resources or post some additional videos that might help explain this maybe in a little different way, something that makes more sense to you. Second option would be to come to the next Google Meet. Today's Friday. Monday is an instructional day, so I'll be posting another video lesson for you. And Tuesday would be office hours, okay? So you'll have an opportunity to come into Google Meet this afternoon, Friday afternoon. You'll have an opportunity to come to Google Meet Monday all day, and you'll have an opportunity to come to Google Meet on Tuesday during the office hours, which is from 10:30 a.m. to 1:30 p.m. All right, you guys, until next time, see you later. Bye-bye.